All right, for the next few minutes, we're going to peek under the hood of the latest and greatest AI models. We're going to see the incredible architectural shifts that are making them so unbelievably smart. Ready? Let's get into it.
So it really all comes down to this one question that honestly feels like it's straight out of science fiction. How is an AI all of a sudden able to read, understand, and remember an entire book in a single shot? This huge leap in memory, or what the pros call context length, is the key to everything. And today, we're going to see exactly how they're pulling it off. But, before we can get to the really brilliant solutions, we have to understand the core problem. See, for years, these large language models have been hitting a wall, a major bottleneck in their memory. So let's break down what that really means.
At the very heart of this memory problem is a little something called the KV cache. The easiest way to think about it is like the AI's scratch pad. As it's writing, it jots down notes, these key and value pairs about the words it's already processed. That way, it doesn't have to start from zero and recalculate the entire universe for every single new word. It's a massive time saver.
But here's the catch. As the conversation or the document gets longer, that scratch pad, that KV cache, doesn't just grow, it explodes. We're talking gigabytes and gigabytes of data. This becomes this huge memory hog, needing tons of expensive hardware and slowing the whole process down to a crawl. This was the wall that engineers just had to smash through.
And smash through it they did. So how'd they do it? Well, they came up with some seriously clever architectural hacks, and all of them attack a central process called attention, which is just a fancy way of saying how a model figures out which previous words are most important for picking the next one. If you make that more efficient, you make the AI's memory way bigger and way smarter.
The three big innovations are grouped query attention, sliding window attention, and multi-head latent attention. Now, I know the names sound super technical. Don't worry about them. Each one is just a really smart way to fix that exploding memory problem, just from a slightly different angle.
First up, we've got grouped query attention, or GQA for short. This is a technique you'll find in really famous models like Meta's Llama 3, and its whole philosophy is about efficiency through sharing.
Check this out. The old way, on the left, it's like every student in a classroom taking their own separate set of notes on a lecture. Super redundant, right? Well, GQA over on the right is way smarter. It's like having the students form a study group where they all share one master set of notes. It drastically cuts down on the amount of information you need to store.
Okay, next hack, slide-in window attention, or SWA. This trick, which you'll find in models like Google's Gemma, takes a totally different approach. Instead of trying to store everything perfectly, it gets really selective about what it even pays attention to.
Here's the difference. The old method on the left is like trying to read a long book by rereading every single page from the beginning before you read the next word. It's just insanely expensive. The new SWA method is like saying, you know what, I'm just going to focus on the last few pages. It restricts its attention to a recent window of text, which saves an absolutely massive amount of work.
And that brings us to our third and final hack, and maybe the most advanced one of the bunch. Multi-head latent attention, or MLA. This is a big part of the secret sauce in those top-performing models from places like DeepSeek AI. And this one is all about compression. And this is a total game changer. Instead of storing all that raw, bulky data in the KV cache, which we know takes up a ton of space, MLA first squishes it all down. It's like turning a massive folder of documents into a single tiny little zip file. The model just has to store the zip file, which, as you can imagine, massively shrinks its memory footprint.
Now, of course, there are always trade-offs. GQA is the simpler one to build, which makes it a fantastic choice for teams that just need a solid, efficient model up and running. But some studies show you might take a tiny performance hit. MLA, on the other hand, is definitely more complex to train and tune, but it can match or even beat the performance of the old, inefficient ways. So if you're chasing that absolute state-of-the-art result, that extra complexity is often totally worth it.
So where does this all lead? What's the next big evolutionary step? Well, the most cutting-edge models aren't just picking one of these hacks. They're becoming hybrids, mixing and matching these techniques to get the best of all worlds.
So a hybrid model works by layering different types of processing. For example, a model like Clune 3 next might use 3 of these super efficient memory-saving layers and then follow that with one old-school full-power attention layer. And it just repeats that pattern over and over. This kind of balanced approach lets it handle just unbelievable amounts of information with incredible efficiency.
And the result of all this brilliant engineering? This number, right here,
1 million. New hybrid models are starting to support context windows of 1 million tokens. To give you some perspective, that's about 750,000 words. We're talking about feeding the entire Lord of the Rings trilogy into an AI in a single prompt. The memory bottleneck isn't just being fixed, it's being completely shattered.
Okay, I know we just went through a ton of technical stuff, but what does it all really mean for us? For you? How does this change things in the real world?
The big takeaway is simply this: that fundamental limit on an AI's working memory, it's starting to vanish. The cost of giving an AI a massive memory is dropping like a rock, and that is unlocking a whole new universe of possibilities.
I mean, this opens the door for AIs to become true research assistants, reading and summarizing an entire library of financial reports for you in seconds. It allows for AI agents that can actually remember your goals for weeks at a time to carry out complex tasks. We're talking about AIs that can sift through a massive software project to find one tiny bug. We are fast approaching a future where we just don't have to worry about an AI forgetting what we talked about 5 minutes ago.
And that leaves us with one final, and I think really fascinating question. For so long, the biggest challenge was just building a better memory for AI. Now that its memory is becoming practically limitless, the new challenge actually falls on us. What truly massive, world-changing problems are we going to ask it to solve